So hello everyone, welcome to problem solving recipes learned from supporting Spark. I'm Stavros and here is Justin. Today we have prepared a set of recipes for you, learned from our work supporting customers which deploy Spark. So we have prepared a bunch of things to show to you. We'll have a look at out-of-memory problems, the no such method thing, perplexities of size, which means long-running tasks which deviate from the median. And also we have a look at struggles in speculation, how you can strategize your joins, how you can recover your stream job safely, and also we have a look at problems with Spark and S3. Now, before we begin and have a deep dive into each recipe, a small prologue. I work as a software engineer at Lightbend as part of the fast data team there. And Justin here is a developer support engineer. And we have been supporting customers along with the rest of the team like for 1 year and a half now. We started this service back in 2015, October I think was the announcement. And so far it's been a great experience because you have the chance to see how a lot of customers deploy Spark and how amazing is actually the work you can do with Spark, and you can help the enterprise software. First recipe here is memory problems. So besides Dory here, you can also have memory issues with Spark. And before that, let's see what is out-of-memory error. So out-of-memory problems start with your garbage collector, as usual, cannot give you any more memory. And in Spark, this can happen either at your driver program or at the worker node, which means you have to watch out for two different things. And you can tune these things to avoid such errors in two different ways, because things can happen wrongly in two different sites. So, as I said, you can have it either on the driver side or at the executor side. And you can avoid having such errors by tuning several parameters. But before you do that, you have to be sure you understand how Spark manages memory. So Spark splits memory in two areas. One is given to you to use it for your own data structures, and also it is used by Spark for some metadata. And the other part is managed by Spark for its execution needs and storage needs. Now, the part that is allocated for execution and storage is usually by default 60% of your heap memory, and the rest of, by default, the rest of 40% is given to the user. Now, within that storage and execution memory portion, there is some fighting between the execution part and the storage part, so they can gain more memory. And within that part, you can always reserve some portion only for your storage. So you don't have your storage memory allocated to the execution part. Now, the execution and the storage part is defined by Spark memory fraction parameter, and the reserved part for your storage can be defined within that memory area with the Spark memory storage fraction. So the storage memory is used by cast RTDs and by defining Spark memory storage fraction, you say that I want this part only allocated to storage, so the execution part cannot steal my memory. And if you have this set up according to your program needs, you should avoid out-of-memory errors. You can always start playing with that, but at the end, your goal is to have storage and execution memory within your old permutation, your old generation part of your heap. And you want that because you don't want to have full cycle GCs often, because cast RDDs and other data from your execution, like shuffle results or aggregations, are usually long-lived objects, and you want that at the old generation space. Also, user data need to be mostly the young generation space, and usually are short-lived. So if you keep that balance, then you should be able to avoid out-of-memory problems. Now, I said you can do that. You can tune these areas and play with them, and you can get more details and documentation, but usually you shouldn't do that, and defaults usually work pretty well. But if you do that, you can use a tool which is called SparkLint, and you can get more about it on GitHub. It comes from Groupon. Also, you have to be aware of the execution time, the object creation and the execution time. You have to check your code and see if you create additional objects, because usually you end up with more data than your initial data set. Also, sometimes you need to allocate and you have to plan for the allocation of your resources on the cluster or where you deploy your jobs. We had a customer who was asking how we can deploy our Spark jobs on their clusters. You have to do this in 2 steps, and this is what we advise. You have to predefine your cluster resources given the machines you have. There are constraints in terms of memory, disk, and CPUs. And after you define the configuration needed at the yarn level, then you move on defining what is required for your Spark jobs. There are several configuration options there. There are a lot more than the ones shown here. So just as a small description here, yarn node manager resource memory configuration option allows you to define the maximum size of heap allocated to containers on yarn, and this yarn scheduler minimum and maximum allocation also defines the minimum and the maximum allocation of heap memory for each container. And then after defining these configuration options and some others not reported here, you can move on and define your Spark, as I said, Spark options. Before you do that and define your Spark configuration options for your jobs, you have to choose whether you go with cluster or client mode, because the configuration options, as you can see in the documentation, vary a lot depending on this cluster or this that's your choice of whether you choose, for example, cluster or client mode. As for the first step, which means setting your yarn configuration options, usually they are by default defined with your distribution. For example, if you launch a cluster on EMR, most of these parameters will be already set up for you. And then you have to, of course, to check the Spark configuration. Another customer also wanted to do something extreme with their output. They had some data, they did some transformations, some processing, and they wanted to come up with one file at the end. This is a case where it's justified by the business, but at the Spark side, it was a bit hard to get this done, because you had to repartition all data in one partition, and that caused memory problems. So sometimes you have to find a compromise here. Just get the flow.
For the next thing, I'm going to talk about a case where we had a problem with no such methods. So the definition here is basically that the class no longer has a definition that you're trying to use. At runtime, if the definition of the class has incompatibility changed, then you'll typically run into this. So let's see the more concrete example here. So the example that we had is the Java lang no such method error from matharrays.natural. So Spark uses math3, and if you happen to be using math3 yourself and the dependencies are off, you're going to run into a problem. So you'll see by the quote that this is an older case. However, even today, it kind of still works. It's probably been fixed for this specific problem, but you could run into dependency collisions at any time. I'm sure a lot of you have already run into them. So basically saying Spark 141 uses math3 3.1.1, which, as it turns out, doesn't have the natural method. So in their custom code, they were using the natural method, and Spark was basically overriding that. So they ran into a dependency collision. And again, that just happens oftentimes whenever you've compiled against one version and run against the next, but the one that you're running against doesn't have the method. So now what do we do to fix that problem? What we're going to do is, if you're able to, now this is kind of a nice place to be. In a lot of cases, you're not going to be able to control upgrading or downgrading. There's many gates in the way, especially if you're working at maybe larger enterprises with dependencies down the line. So you can upgrade Spark or downgrade it, or you can upgrade or downgrade the library itself. But again, that's if you're lucky. So the other thing you could do is you can enforce the library load order. So you can set driver class path to a jar containing the math library or whatever library that you're using, and make sure to specify that. So now whenever a Spark runs, it's going to make sure that this is the item that's going to be used. And the last thing, and the one that should fix it once and for all, but kind of adds a slightly more complexity to it, is you can shade your library. I've given you the links. SBT and Maven both have ways to easily shade, but what shading is saying, hey, we know that there's going to be two math3s in there, and it's essentially going to rewrite your code so that the one that's shaded, it's going to say, hey, it's going to act as if it's not really math3. It's kind of a separate thing so that it'll rewrite it and essentially shade it so that Spark's version doesn't clash with the version that you're using in your own libraries. All right. So the next thing we have is more of a general recipe. So a lot of the ones that we have are specific cases because we want to give you ideas to take home and to be able to use right away. So this one's more general. And it's kind of the problem of Goldilocks, not too big, not too small. So a lot of times if you're trying to factor, it goes back to your resources. If you're trying to factor things, you don't want things to be too small because then you're going to end up with too much overhead and you're going to be spinning your wheels a lot. Whereas if it's too large, then you're going to have idle resources and you're going to have execution skew. So what you can do is you can kind of take the example from HDFS. They kind of have default block sizes, 256 kilobytes. But as a general rule of thumb, what you want is a bigger number than the number of cores that you have. Typically 2 to 3 times the number of cores to maximize your parallelism. However, in one example we had, if you really have a lot of large computation time, then you can increase this to 4 or 5 times. But it's going to depend on your cases here. I'd say a good rule would be to start at 2 or 3 times. Let's see here. And so one way that you're able to tell this, it's a little bit small, but I'm sure most of you have seen the Spark UI. The way that you can often tell if you have execution skew is to take a look at your median runtime and your max runtime. And what you're going to want to run into is you don't want those numbers to be at 10 times difference. I mean, that's going to be a real extreme. If it's 10 times or more, then you definitely want to maybe take a look at sorting by duration, see if it's maybe a node slowness or just if you have a lot of spinning going on. Okay, and so the next thing I'm going to hand off back to Stavros, which is struggles in speculation.
So speculation is a cool feature in Spark, which actually says if some task is slow, try to relaunch it on some other node. And usually you see that when you have a node that is faulty, there is some network problem, or for example, a network card is again faulty and there is some problem, and Spark manages that in a smart way with speculation. So there are 3 parameters there. One is which controls speculation. One of them is the Spark speculation interval, which is the interval, defines the rate at which Spark polls tasks and checks how they behave, so it can launch speculation. The other parameter is Spark speculation multiplier, which defines how many times a task must be slower than the median so that it can also be considered for speculation and to be relaunched somewhere else. And also there is a third parameter, the Spark speculation quantile, which defines again the percentage of tasks that should be completed before speculation should be even considered. And we had a customer who had a very big cluster with 1,000 nodes and 3,000 cores, and there was this node that didn't behave very well. And the customer came to us and said, how can trigger speculation in a smart way so not all these resources are held by that job, because the end result was no one could use the cluster. We said, okay, you can trigger speculation after 95% of your jobs are finished, because the trick here is that you want to have progress and don't want speculation to be triggered early enough, but you have to watch for the rest of the 5% of your pending tasks and how long the relaunch tasks will take. Because eventually you want to hide this cost of relaunching tasks within these 5% of normal tasks, health tasks. So this is one heuristic you can use. In general, you want to be this speculation thing happening as transparently as possible. Another thing important which we have seen with customers is joins. Joins are everywhere, and there are many things that you have to consider about joins. Two important things are joins which are slow and joins you cannot avoid. So one thing you can do with slow joins is that when you have a small data set and a big one, you can use a hint there and make the small data set available on all your nodes with broadcast. But this is not, as you saw, we use a hint there broadcast, but this is not enough. You have to make sure that the actual optimization is triggered. And the only way to do that, to be sure that this is done, you have to check for the actual execution plan there. And you have to see a broadcast has join reported. Otherwise, you don't get the optimization. There are several join strategies in Spark. The one I just mentioned, the broadcast has join strategy. There is the shuffle hash join strategy, the short merge join strategy, which is the default. And you can configure your strategy and the threshold for broadcast, and you can configure other options for your join strategies from your configuration in Spark context. Now, for the unavoidable joins, there was a specific case with one customer who wanted to do a group by on a data set with multiple columns and then an aggregation. And he wanted also to keep all the rest of the columns of the data. This is not provided right now the data frame DSL. So what you have to do there is explicitly do a join. So you have to make a compromise here again. Now, let's talk about the safe stream recovery.
Okay, so
Justin.
Safe stream recovery. This was a case where, let's see. Okay, yeah. So this was a case where a customer wanted to load from Cassandra, cache it, and then use that data inside of a transformation. So all of this looks pretty easy, pretty normal. Everything should work. Everything is working, and it works. Great, until it doesn't work. So basically, the stream crashes, and what happens whenever it crashes, it should just recover, and everything should get back to running happily. Well, what you end up with whenever it tries to recover is this error. So it's a bunch of gobbledygook, but the key here is RDD transformations and actions can only be invoked by the driver, not inside of other transformations. It's a very confusing error. It actually doesn't entirely tell you what was going on. And in fact, you're even more confused because the code was running up until it tried to recover. So why the difference? They should essentially be the same thing, right? So let's see why it happened. We'll go back to the code here. So the problem is that you're joining on this product. So whenever you pull in an outside RDD into your transformation, then the inner streams of D streams will essentially choke on that, and you get that problem where it's saying, hey, you can't have an RDD inside of there. So the way that you're going to solve that problem is by loading your RDD, loading your Cassandra table within the transformation. So as long as it's done within the transformation, you can then join on it, and it's happy. Right? So that's the general case. But remember that, I mean, now you're going to be constantly loading on each join. It's not that efficient. We wanted to cache it, right? So a little bit of a bonus recipe here. So what we're going to do here is we're going to expand this a little bit. And what we're going to say is, hey, let's go in this transformation and say, let's get all the persistent RDDs. We're going to go off of a name of the RDD and say, hey, that's going to be our product. And if we get it, we're going to get back a sum of that RDD, and we can just cast it to the Cassandra table and use it down here as you need to. Otherwise, you're going to get a none, and you have to load it. But the key item here is that you have to set the name, because that's what you're checking on. So you can still get caching as long as you add this little bit of extra code. So get the whole solution there with caching. Everything's working. All right, so the last case that we have here is handling S3 without hanging. All right, so what does that mean? We have a simple code here. We load our streaming context. We say, hey, load our text file stream from S3, and then just print. Really simple, should work. You expect it to work, right? All right, no. It's going to spin and spin and spin and spin, and then sometimes it'll work. So let's find out why. Basically, S3, at least in the streaming case, will try to even though you're streaming it, it'll try to download the whole thing first. So if you have a ton of files in that folder, it's not going to say, hey, give me one, give me the next one, give me the next one. What it's going to do is it's going to say, give me it all, and then you can handle it as you want. But I mean, that's not really what you want whenever you're streaming. So it just chokes and it just hangs. So a few solutions that you kind of have at your disposal. So one is you can paste it with a script, so you can write your own script and offload things and monitor your files on that folder so that it says, hey, I'm only allowed to have 5 files, and then store the rest in an off location. Pain in the butt, but it theoretically can fix it. Along the same lines, maybe a little bit more code happy is you can write your own S3 handler that will actually go out and handle this in a streaming fashion. Additionally, there is a Stack Overflow answer here where you can do explicit file handling. So you can actually, it's kind of similar to the custom handler. What you can do is you can say, instead of having it go and get the S3 for you, you can say how many files are there in S3, and you can have your code pull down the list and do it in more of an iterable fashion. The simplest solution is increase the heap size. So if you're able to increase your heap and that works for you, then that's great. It's not going to scale, but if it works, you can try that at first, and at least if you're maybe in production, it'll fix it in a quick way. But again, you probably want to solve the problem more at hand. The other thing you can do is complain to Amazon and have them fix their S3 handler. I think we've heard that they may be actually in the process of fixing that. We will need to double check on that. But as far as I know to date, it's still a problem, so you have to work with these other solutions. All right, so that's all we have, but there are definitely more recipes out there. There's more problems. Lightbend offers support, as Stavros said. So we've got a fast data platform product that we're rolling out. Feel free to ping us and see about what we can offer you. Otherwise, I think we have about 3 minutes for questions.
Questions?
I was just curious on EMR, the sort of defaults they come up with those various options. Are they more skewed towards cluster mode or the client mode?
You have to think about how you deploy your jobs, but I think cluster mode is more of a first option. For example, you may want to have a recovery of your failing driver. So
yeah, I'm definitely all for cluster mode. I guess I'm just wondering, like when you use EMR and you use their defaults, or maybe use their maximize resources option, do you are those options that it sets for you, are they more geared towards or optimized for cluster mode or client mode?
The defaults, you mean? When you launch the...
do you know offhand?
I think they're cluster, but you don't quote me on that without digging into it. It's been a while since I've dug into the EMR side of it, but I think that they focus more on cluster. But again, not 100% on that.
All right, thanks.
Thank you. Hi. Earlier, you were talking about joins and the explain plan, checking the explain plan. I assume you were pointing that out because at times it might be that the plan doesn't work out the way you think it should work out. And so in those cases, what do you do?
In case you have a specific strategy and it is not triggered, or what?
So right there. So you said, okay, make sure that.
Okay. There is a configuration option to set the size, so this strategy can be triggered. The broadcast has joined strategy.
Yeah. So you're going to typically want to set your auto broadcast join threshold. I mean, that's usually more for it'll do it automatically, but that also can sometimes get in the way of your hint. If the hint is too big, then you can start playing around with this configuration.
I guess just a more kind of general question on using S3 with Spark. when S3 is eventual consistency and only have like read after write consistency, strong consistency. So how do you deal with say cross-cluster? Say you have this cluster write to S3 and then another cluster read from it, and then because I think Spark do a list operation to get the file, and that's not consistency. So how do you deal with that?
You mean on EMR?
Yeah, from EMR. Or
Yeah, there is an option to use some optimized file system there, MRFS, I think is the name.
Yeah, but EMRFS is only within the cluster, right?
Yeah.
But what happens if it's across two clusters?
Yeah, I don't know if there is a solution out there for that thing.
Yeah, I think you're going to typically want to running into something similar to kind of your CQRS type problem. So you want to look at solutions along those lines where it's like where eventual consistency is where you're running into. You have a read and a write side. So since we're out of time, the short answer is I would kind of look down that path at solutions that people have proposed there.
Okay, thanks.
Okay, so we're out of time, guys. So thank you very much. Please show your appreciation. Thank you.